And we have liftoff.
After the first servicing mission to the Hubble Space Telescope. Hubble amazed us with its ability to see clearly into our universe. But Hubble can also see things that our eyes don't naturally see, even if we were up close. We would actually see something that looks more like this. But how can we see this then, when our eyes would actually see something that mostly resembles that? And the answer to that question lies within Servicing Mission 2.
Liftoff. Discovery now on its way.
Houston, Discovery.
When Hubble was first launched into orbit, much of the technology that's aboard today didn't even exist yet. That's what makes Hubble so unique. Over its lifetime, Hubble was able to be serviced 5 times, allowing us to fix parts that may have been worn out and add new instruments that have been specifically crafted to enhance Hubble's performance. Now, up until Servicing Mission 2 in 1997, the Hubble Space Telescope could only capture light within the visible to ultraviolet spectrum. And even though our eyes can only see within the visible range, NASA was after a wider reach into the spectrum of light. By widening the range of light that Hubble is able to capture, astronomers could see into distinctly different windows into the cosmos. This is because a picture is worth 1,000 words, but the light that formed that picture also has a story to tell. And here's where spectroscopy comes into the narrative of that story. Spectroscopy is a technique that scientists use to separate light into its component colors or wavelengths. And by separating light into its components, we are able to unpack greater detail about the space around us. So, NASA constructed the necessary mechanisms needed to capture a wider range of light. They spent years combing over every detail of these new instruments and trained a team of astronauts the techniques needed to install them properly into Hubble.
The purpose of today is for the crew of the second servicing mission for Hubble to get familiar with installing a science instrument into the telescope.
After the proper preparation of the new instruments, all of the components of Servicing Mission 2 were ready for launch in the February 11th, 1997 mission.
Ignition and liftoff. Discovery now on its way to service NASA's Hubble Space Telescope.
Complete aboard Discovery. The vehicle's now in a heads-down position on course for a 28.5-degree, 309 nautical mile orbit.
Good morning, Discovery. It's the day to go grab yourself a telescope. Hey, good morning, Chris. We're ready to do that.
During this mission, the team of 7 astronauts installed the Space Telescope Imaging Spectrograph, or STIS, to Hubble, allowing us to separate ultraviolet and visible light into its components, giving scientists critical diagnostic information about an object's composition, temperature, motion, and other physical and chemical properties. Also with STIS, Hubble was able to capture in a single exposure a spectral region 30 times wider than previous spectrographs. Now questions surrounding the study of massive black holes, stellar flares, the evolution of the universe, and distribution of matter could now be studied in fuller view. But NASA did not stop there. They also installed the Near-Infrared Camera and Multi-Object Spectrometer, or NICMOS, which allowed Hubble to see into the universe by infrared light. We can now tackle questions like, how do stars form? How many stars have planetary systems? Or, how do galaxies form and evolve? Additionally, the astronauts of Servicing Mission 2 refurbished a fine guidance sensor and gyroscopes, all of which help point the telescope. They repaired failing thermal blankets, which regulate Hubble's temperature, added a better data recorder and data interface unit, which all help manage Hubble's data intake, and replaced the electronics that drive Hubble's solar arrays. now, more than ever, we are able to see into the universe in a rainbow of colors that were only a dream in the early 1990s. Servicing Mission 2 went down in the history books by making the Hubble Space Telescope more scientifically powerful than ever before.
Proves that you all have done a great job, so many thanks to all the people and all the other ground locations supporting this mission. For we understand the sacrifices you made to make sure this mission was successful.